Hey guys, welcome back to Crash Course. I'm Nishant, and today I'm going to show you guys how to convert your CAD files into mesh files so that you can import them into Blender and use them to render out images. I'll be covering different softwares like Onshape, Solidworks, Fusion 360, and Inventor. So to get started, there's a few basic tenets about converting from CAD to 3D that you guys need to know about. In CAD, the main file type tends to be parasolids, which include things like steps, IPTs, solid parts, solid assemblies, IAMs, things like that. In Blender, you would use things that are 3D file types or meshes. These include things like STLs, OBJs, or FBXs. So now, of course, the question is, which file type should you use to convert from CAD to 3D? For smaller assemblies, converting directly to OBJs or STLs tends to work pretty well, as the files are small enough that they won't lag out your computer when you import them into Blender. However, as you get to larger assemblies, and especially larger parts, converting to OBJs and STLs can lead to ridiculously sized file sizes and can lag out your computers intensely when you import them into Blender, which is why for larger files and larger assemblies, it's best to convert them to a .fbx file type. Since most CAD softwares tend to have direct conversions to OBJs and STLs, I'm not going to be showing that in this video. I'll instead just show the conversions to .fbxs, as those are the most uncommon ones to find and the often hardest to do. To start off, I'm going to show you guys how to export FBX files from Fusion designs you create. You may notice in Fusion 360 that the actual software has no place to actually export your designs to a specific file type. And you're right. You can actually find these functions in its companion website, a360.autodesk.com. So let's go navigate over there real quick. So if you search up A360 on Google, you should come across a page that looks like this. You'll have the A360 logo in the top left, and you should be able to sign in right here in the center. So if you sign in to your Autodesk account, you should get to a page that looks like this. Here is all your files that you have from Fusion 360. I'm just going to go navigate over to the logo that I want to export to FBX. And simply all you have to do is select which file you want to do. I'm going to select the FTC logo. And up here, there's an export function which you can use to export to whichever file type you want. And as you see, there's an FBX function. So if I click this, the logo will be exported to FBX. And in my email, I will get an FBX. You may notice that it said that it'll take up to 7 business days. Don't worry about this because normally it takes upwards of maybe 10 minutes to an hour to actually get the file to you. It doesn't take as long as it says. So a thing to note when exporting to FBX in Fusion itself is that while it does for assemblies remember that the parts are the same, it does not convert mates or constraints into Blender simply because there's no real analog for them in Blender. So if you want parts to move together or move in a certain way, you'll have to do the animations in Blender itself and parent the objects yourself. So now that we've covered Fusion 360, let's move on to Inventor. So Inventor has no default convert to FBX function, which means we have to take use of Fusion 360's convert to FBX function. There's two main methods of doing this. The first method is to simply use Inventor's export to CAD format function, which you would use to convert to a step, which you can then import into Fusion, and then you can use Fusion's A360 to then convert that to an FBX. So the second method for converting Inventor files to FBX is to take advantage of Inventor's pack and go function. To access the pack and go function, click on File up here, click on the drop down for Save As, and then open the pack and go function. You want to select the file you want your pack files to go into. I have made a folder for that called pack file. Then search for whichever files you need in the actual project. In this case, I have all the files I need. Then click Start. Once this progress bar has reached the end, it means your files are now packed properly. Then click Done. Then you navigate over to Fusion 360, click on the Upload button, and then select Files. Then navigate over to the file you saved your other files into, called Pack File, and then click on Workspaces, navigate down, and then select all the files you have selected. Then you want to simply select our top-level assembly file, or rather what you want the name of your file to be. So I'm just going to set the drone frame assembly to be the actual name of the file. Click Upload, and wait for it to upload to Fusion 360. This can take a little while or a long while depending on how big your file is. However, it's worth it to get the actual FBX. The main reason you want to use Pack and Go is simply that it helps you keep track of all your files without having to manually find all of them at once. Once your file has finished uploading to Fusion 360, you can simply navigate back to A360 and then export as FBX. So now that we've covered both Inventor and Fusion 360, let's move on to Onshape. So Onshape, like Inventor, has no direct CAD to FBX conversion, so we'll have to go through the medium of Fusion 360 again. So let's say I want to convert this piston assembly that I made to an FBX so that I can animate it in Blender. So simply right-click on the assembly or the part that you want to export, and there's a little option on the bottom to click Export, and then download the file. As you can see, you can only convert it to a set amount of files. The fastest way I've found for me is to simply convert it to a step, download the file, and once you have the actual file downloaded, simply move over to Fusion, click Upload, and then select the step to upload. Again, the actual upload time depends on how big your file is. So once your assembly has finished uploading, you can simply open it in A360 and download as an FBX. So finally, let's move on to Solidworks. So Solidworks, like Onshape and Inventor, has no built-in FBX function. However, you can get add-ins like the Solid Sim and the Solidworks Visualize to actually convert to FBX. However, both of them cost money and or need a license. So the easiest way, again, is to convert to a step and then import it into Fusion and then convert to an FBX using A360. While Fusion can directly upload solid parts into itself, for example, as you can see here, I can simply select a SolidWorks part. For assemblies, it requires you to have the rest of the parts in the assembly. So for example, if I want to import this rev hub assembly, I need to select the files that the rev hub assembly has in itself. So while it's easy to simply import singular step files or solid parts, for assemblies you have to know all the parts that are involved with it, which is why it's generally easier to simply just convert to a step and then import that step into Fusion, after which you can then convert to an FBX using A360. So now that we've converted our files to .fbx's, let's go over how to actually get them to Blender. So simply click General to create a new general file. Delete everything in it. Then scroll up to File on the top left, select Import, and then select FBX. Then scroll over to wherever your file is located. Mine is in Downloads. Select the file, and there you go. You now have your CAD file in Blender. I'm just going to rotate this along the x-axis by -90 degrees so it's in the correct position. And there we go. I successfully moved a file from, in this case, Onshape to Blender. Now, you might also notice that you can also export files as FBXs from Blender. So technically, if you need to, you can import a file from a CAD software as an STL, and then convert that to an FBX using Blender itself. However, at that point, Blender can run your file quickly enough as an STL, then you might as well just start rendering with the STL itself rather than converting to FBXs. FBX is only if you have extremely large assemblies or extremely large parts. And that is basically it for this crash course, as there's not much else to be said. If you guys have any questions, feel free to leave them down in the comments below.